Good afternoon, everybody. My name is Kevin. Welcome to the ESP32 product creation journey. Today's going to be, it might be a crapshoot of a stream. We'll see. We've gotten to the point where we need Wi-Fi connectivity on our device, and so we're going to play around with the unified provisioning component that comes packaged with the ESP-IDF stuff. So there are lots of different approaches to getting Wi-Fi connectivity working on your device. So again, we're building this little development board / product with an ESP32 room module on it. And Internet of Things products and devices are always a chicken and an egg problem. You need to get them connected to your Wi-Fi, typically Wi-Fi, to get connected to the internet, but you also need a way to get the credentials on there, and that often involves Wi-Fi as well. And so, like I said, chicken and egg. And for technical people, it's pretty straightforward. And you've probably done this with 100 other IoT devices. For a mainstream consumer, just in delivering these puck products to people, again, there's no buttons on it, there's no switches, there's a USB port on it, but the idea is you plug it in, use your phone to get it connected to your Wi-Fi, and mostly smooth experience, but the less technical consumer struggles with this. And so for your maker projects, you'll just go in to the IDE that you're working in and just likely hard code your username, your SSID and your Wi-Fi password, which I never recommend, by the way. I mean, we all do it for one-off maker projects where we're just dinking around, but for any kind of device that you're going to give to somebody else, like that's obviously not a workable solution. So it's time. We need this device to be connected to the internet, so I'm going to mess around with like I said, the unified provisioning stuff to get it connected. Now, again, I'm going to be transparent about this. Like, I don't know how this is going to go. This might be a super boring stream because I don't have anything prepared. I'm really just going to slog through it. Maybe a couple people join. We can chat, answer some questions, but and I'll talk through it as I'm going through it. So let's get started and see where we end up. And I'm going to need to refill that water for sure. Okay, so this is, I feel like I need to give a little bit of background here. So if you come into the docs under API reference, there's provisioning, and then there's unified provisioning. And this is where we are. SmartConfig, if you've ever heard of that, is it's like it says here, is a provisioning technology developed by TI to connect a new Wi-Fi device to a Wi-Fi network. SmartConfig is what the puck product uses now, and it works fairly well, but it's a little clunky because, again, if you're not technical, you have to go in, you go through some steps, and then the steps will tell you, hey, you have to go into the settings of your phone and connect to a different Wi-Fi network. And technical people all day long, they've got this. Your mom, your grandma, your grandpa, your aunt, your uncle that doesn't do programming, this is a real stretch. They probably didn't set up their Wi-Fi in the first place. And so makes it hard. Even like I have very specific instructions. Let's actually show it real quick. Setup.mysmartpuck.com, I believe is what it is. Let's take a look at it. So this is what I tell people for when they get a puck, there's an instruction card that tells them to come to setup.mysmartpuck.com. First thing that you'll notice is not secure. And that has a bunch to do with the Particle P1 and not being able to do HTTPS without using like all of the onboard flash. And again, I put a little warning here to say, like, you may have a warning in your browser telling you this page is insecure. And I like explain that because sometimes people see that, like they're told by their techie son or parent, like, don't proceed if it doesn't have the lock. And so I have to explain that. Again, this is the soft AP approach. Click Get Started. You click Get Started. Oh gosh, why are we? It's apparently it doesn't even work on Brave. Why would it? do I have to do shields down? I'm gonna like hate myself. See, like I don't have any trackers, so I don't know what it's blocking. Interesting. Let's do shields down. That's really interesting. I'll have to look at that later. There we go. Get started. I promise I have no trackers that I'm aware of. I guess I'll have to look into the code. There's not much to it. Anyway, so yeah, again, being as clear as possible to help people understand how to do this is really important. So I'm like, plug the USB cable that was provided into your puck, and then click next, and then plug it into power, which if you remember from previous episodes, you cannot charge from a laptop, but you can provision from a laptop. And then hit next. And then I even do this, like, are you on an Apple, Android, or a Windows device? And depending on what you click here, like, we'll do Apple. Are you on an iPhone, an iPad, a Mac? Like, to walk people through this as, you know, hold their hand as best as you can all the way through. This is the kind of process you have to have, or people are going to call tech support, and they're going to call tech support anyway. And when you're a company of one, you are tech support. That's me. And so I'm trying to avoid that. So, and that's because on each of these devices, the screens look slightly different. And so I spent hours building. So like, oh, I'm on an iPhone. So I click that. I show the exact steps to do on an iPhone, like open the settings app. I show like the icon. And anyway, keeping all this maintained, let's go through this again. Let's say get started, next. Let's say Android. Okay, here are the steps on an Android device. You know, different icon. Here's what the dialogues look like, and walking through how they need to switch to the network that your device is currently hosting so that they can connect to it. And then once you click next here, it's going to actually, it assumes you're connected to the AP of the device, and it'll try to go through that and give you the rest of the steps. And so this is soft AP, otherwise known as SmartConfig for those that may not be familiar. So that's what we currently use. So we could do SmartConfig. Like I said, you could even do something just like where they plug it in and over serial, have a little program that looks for the device connected to serial, and you pop out some prompts of like enter your SSID and your password, in which case they can do that. Which, saying that out loud makes me think we should have that as a backup just in case. Like, find a computer, plug it in, and maybe provide an app for it. Anyway, all these things you got to think of, because otherwise, when people get the device and they can't get it to work, they're not happy. Like, you get a nasty email. So what I want to try a little differently here with this unified provisioning, let's go back to that. Unified provisioning. It talks about how, here you go, transport flexibility. The protocol can work on Wi-Fi, soft AP plus HTTP server, SmartConfig, or on BLE. Now, the reason I'm interested in giving BLE a try, it creates a little bit more complexity for me, but it makes the customer experience a little, I should say a lot more complexity for me, but it makes the customer experience much nicer in that, and this is where I'm torn. They'll have an app on their phone. It's a native app. They don't have to worry about switching networks. They just, like, it will find the device directly, like phone to device, and you can provision the Wi-Fi that way. Much less room for error in, like, I don't know how to switch my network. One of the big things on, bought test devices here. Like, I bought an Android phone just to have as a test device to make sure my processes work well. One of the things that Android does is when you connect to soft AP on a device like this, is it tries to connect to the internet through it, which does not work. That's not the point of it. And you get like a burp sound, and it says, we could not connect to the internet through this. And I even put that, all right, let's go back. Right here. Your device will notice it can't get to the internet through the puck and might show a notification like the image below. Internet may not be available. Like, I put that in the instructions to let people know, don't worry about that. It shouldn't connect to the internet. That's part of the process. But I've had people reach out through our support channels to say, it says the internet's not available when I do this. And so it's not working. It's like, oh, it's working perfectly. So anyway, like I said, as little friction as you can have with the BLE. If you have an app, It's very straightforward. It's all contained within there. Anyway, so that's why I'm looking at BLE. The thing I hate about BLE, and I would love to hear other people's thoughts on it, is I'm apped out. Like, I just had we just had a generator installed, home generator, and it has an app to get it provisioned, which I totally get. Like, the installer was trying to explain it to me. I was like, I get it. I know exactly what this thing is doing to try and connect to my Wi-Fi. But it's like you need an app for everything. And I kind of hate that. And I'd be contributing to it with this unified provisioning. But again, it's a balance between making the process smooth versus, having an app, which again, maybe I'm irrationally against. I was going to say one more thing about that, and I can't remember. So anyway, that's where we're at. We're going to play with unified provisioning and see where we get. This could be a boring stream. I apologize. But that's where we're at. Okay, so that's unified provisioning. And if you dig through the ESP-IDF examples, there's a provisioning folder. There's a Wi-Fi provisioning manager, main, appmain.c. One thing I would like to point out, if you are going through this process, let me find it here, ESP-IDF jumpstart. I was going through this jumpstart documentation, and as ESP points out, like, this is the build a production ready, and like that production ready flag is really important to me because I'm not looking to make a maker product here. This is a consumer product, and so this was like, here's our the expressive template for doing that. And so I was kind of using this as a template until I got to the Wi-Fi connections section and noticed that it says TCP IP adapter init. That is now giving you warnings in ESP-IDF as soon to be deprecated. And so this is how it's always been in ESP-IDF, but that is not the case anymore. So they have not updated their ESP jumpstart template code to include the new way. This will still work, but you'll get a lot of compiler errors saying like deprecation warning coming, which, as with all things, if you're making this stuff, I would recommend against using to be deprecated things right off the start. Like, we might as well, since we're starting fresh, we should use what the going forward way is. And so back to our example, you'll notice here, the way you can tell if you look at this, well, first of all, I think if we search for TCP, oh gosh, that's not what I meant to hit. TCP IP adapter init, I believe we won't find it. Now make a liar out of me here, GitHub. Yeah, okay, so you won't see that. But there's the new way to do it, and this is how you can tell new versus old, is this ESP net interface init. That tells you that we're doing this the new non-deprecated way. So if we look at this code, it's not very long. 282 lines of code, and there's actually a bunch of if-def sections here because this supports both the transport of BLE or the soft AP SmartConfig way. And you'll see that here, like config example, transport soft AP or transport BLE. Again, I'm going to do BLE just to see how it goes. We'll see how it goes. That's what we're going to find out today. So, do we just copy pasta this? I mean, maybe. You know what? We're going to kind of, we're going to yes and no copy. Paste. Okay, so let's grab all of it. And now over here we have our main.cpp. That is the basis of the project that we've been working on. And what I'm going to do is I'm just going to come underneath here, paste it. And then, because again, we can gut everything that is not BLE transport and keep everything else. And so let's just come up here and let's grab. So I'm going to gut the code because I was going to start copying and pasting up, but let me come through, gut the code first. So if def config transport BLE, like this is the code we want. And the soft AP we do not want. So we're just going to take whole swaths of code out here for anything that's soft AP related. Come through here. So not too much. So we can get rid of this. Okay, so yeah, so the Wi-Fi provision manager config will want the BLE version. And we'll take that whole thing out. Any default scheme specific you would like to choose. Since our example application requires neither BT nor BLE, we choose to release the associated memory once provisioning is complete or not needed. This can be set to none. Oh, okay. So yes, this is important because Bluetooth BLE is a major memory hog. And so our end application, at least mine in the case of the product, will not need BLE at this point in time. It's always there if we ever want to use it in the future. And so we do want to free everything up to get all that memory back when we're done provisioning. So let's go ahead and wipe out the soft AP code here, and we'll leave this. And then we can get rid of this comment for now because we know that. Okay. Here we go. So now, like, it's kind of a nice, I mean, I'm interested to see how well this works. Wi-Fi provision manager is provisioned. So like this is going to check like, do you already have Wi-Fi provision? And what we're going to really need to dig into is like, what happens? How does this work if somebody's changed their Wi-Fi password? Because I've had a couple of customers with that as well. They call up and they're like, it's not connecting. And it's like, well, did you move? Did you change your Wi-Fi password? Like, oh yeah, I changed my Wi-Fi password. Like, why should that matter? It's like, well, the device needs to know about that. And so I believe is provisioned is only going to check like, do I have credentials stored? And so we'll have to have some down in the else here, way down here, already provisioned starting Wi-Fi STA. Like, I feel like this could fail if you change your credentials. And so something to be aware of that we're going to have to take into account. Okay, service name. What is the security level? There's lots of documentation about this. Security level 0 is simple plain text communication. Security 1 is secure handshake with proof of possession. We are going to want to use that. And that's if you start broadcasting and you're close enough to a neighbor, these devices don't have a huge range, but the use case is like your neighbor sees it, connects to it, and claims it. And now they have configured your device. The proof of possession is normally like if you've ever paired like a Bluetooth keyboard or something, it tells you to type a specific set of keys, and that's how it knows like, okay, you're the person that's doing this. In our case, we could print like a little code, device specific code on the display and have them prompt them to enter that. And so we do want security 1. And this is the proof of possession token, which, you know, we can worry about customizing later. And what is the service key? This translates to the Wi-Fi password in the scheme. Is that simply ignored? Okay, so I guess just leave it as null. If transport BLE. So I don't know. This is we need to set a custom service UUID. I think this may be specific to their app, which we're going to download and hopefully be able to provision with, depending on how far we make it through here. But we can get rid of the gate around the BLE code here, because we do want that. This custom endpoint we'll play with, so we'll leave it there. Custom data – already provisioned. Okay, I think we've gotten rid of all of the SmartConfig specific code. Now let's just start pulling this code up in. Let's see how this goes. Okay, so the first thing I'm going to do is I'm going to take all these headers and come up to here and see, like standard IO, I've already included. String, we need, I'm going to put it up under standard IO. Free RTOS, I've already got. I'm including it a little differently. Task, I'm already including. Event groups, I just learned about last week. Super cool feature. Oh, that's not what I wanted to do. If we're going to include like this, let's make them all like this. I don't like the... Let's do this. Okay. That's just a pet peeve. ESP log.h, we do not need to include because if you recall, we have our own logger. Wi-Fi, ESP event, and NVS flash. We're going to need all of these. And we can look at moving these off into a different file later, but for now, this is fine. And we're going to need these provisioning things as well. Okay, so that should be our fully stacked out include. Lots of dependencies. Okay. And then a lot of these are all just Spark, hey, what's up? Really appreciate you watching everything on YouTube. Positive feedback. You're awesome. Thank you. All right, we're going to take everything above app main because these are just helper functions. Whoa, we went too far. And we're just going to hoist them above our existing app main. So we'll just stick them all up here. And then we're going to have to change some of them. And then that just leaves the app main, which is really long. We'll come back and we'll do that last. Sparky, just joining, what we're trying to do is get unified provisioning working. So we want to use for now, the default ESP provided provisioning app that you can download from Google Play or the Apple iOS App Store to configure our Wi-Fi. Yeah, welcome any and all questions. I don't promise to have answers, but you're more than welcome to throw them in there. I'm happy to try and help as best I can. So the idea is hopefully we'll be able to set our Wi-Fi credentials on our board through a phone app. So that's what we're playing with today. Okay, so one of the things I know I want to change in here is you see all these ESP log I. We are going to change out to use our serial logger, our log manager. So we'll do logmanager.info. To make our code a little more friendly. So we're going to just take this. One of the things I love in VS Code, if you're not a VS Code user, if you are a VS Code user, is if you highlight something and you press Control D, it'll highlight every instance of those. So this really saves on code refactoring. You can see that. And now what I'm going to do is you can edit it. So I'm going to back ESP log I out everywhere where it's at and replace it with log manager info. And that should be all we need to do there. It replaces it everywhere, which is pretty cool. And then we'll do the same with log E. Do that out, but instead of info, we'll change it to I don't know that. Let's go back. Control D. It'd be nice if I could see two of them on the screen at once. Looks like there's only two instances of it. Okay, so get rid of that. Push it in, come back, change it to error. save that. And the other one was down here. So let's just make sure it did that. Or wait, the other one was up here. Log info error. There should be another. Oh, it was down here. Error. There we go. Okay, so it did replace them. Great. I don't know if there's any down there or not. Okay. And so this is all just standard. I don't love, one of the other things that I don't love about some of this code is the use of ESP Error Check. So this is a macro in ESP-IDF that whatever you wrap in it, if it does not return ESP_OK, it just calls abort, which in ESP land is basically a reboot. Like it just and it resets and starts from the beginning. And there's a lot of these where, again, if you're just building like a little test script or a maker project where it's like, that's fine. But in the case of a product, like there's a lot of these where if something goes wrong, we don't want to just completely blow everything up and try again. Like we might want to, handle that more gracefully. And there's sometimes where it's just like if a low-level ESP-IDF call fails for whatever reason, then yes, we do just want to restart and try again. But like this ESP error check is heavily used through a lot of the ESP-IDF sample code. And because of that, anytime any of this stuff fails, like if Wi-Fi start fails for whatever reason, I believe even in the main documentation it says you can try again in a few seconds. But in this case, the try again will happen because you just rebooted, which maybe is a poor man's way of doing that, I guess. Okay, so all this code should be fine. I want to understand this code, but I'll do that after. Let's just see if we can get it to work, and then we'll worry about understanding it. Like if it works, then we'll dig in and make sure we understand. Now, something I'm going to change then looking through this is, because I'm sharing all this, is received Wi-Fi credentials, SSID, and password. I don't really want to show you, show that. So I'm gonna get rid of these and just say just fill them in like this. Sorry, I'm not sharing my Wi-Fi. I do want to set up a test network at some point, just like a dummy router, to do more extensive testing on some of this stuff instead of hooking up into my main Wi-Fi. Provisioning failed. Reason, provisioning successful. Great. So this all looks fine. This is all in event handler. So all the events will go through to this. Init STA, great. Provisioning. This is the MAC address. Cool. Custom data. Like, I don't really know how that's going to work. And then, great. Okay, now let's take the main. And you know what I'm going to do for now? Let's just take this entire contents of main and just, since we're playing around. Okay. Let's just replace my while true here. Eventually I'd like, and then it'll just say hello world over and over and over. Log manager. I don't know. Let's try and build it. See what happens. I don't know if this is going to work. ESP Error Check. Let's build. Figure there's like I was going to say less than 1% chance. No such nvsflash.h. That almost assuredly is going to be under, oops. Like a free RTOS. Should probably be under, let's just come into like the docs for it. Header. nvsflash include nvsflash.h. well. I wonder if it's FreeRTOS. No. NVS Flash slash. It seems like it'd be weird to have to do include slash. I mean, let's try that, but that seems wrong. Seems like a header's not being included the way it should. No such file or directory. Okay, it's not complaining about anything else. Okay, something is off. Let's comment this out and see if it complains about any of the other ones. It doesn't like Wi-Fi provisioning manager either. Why? I feel like this has to do with menu config. Provisioning. NVS. I've got Wi-Fi NVS flash, so anything related to NVS looks to be enabled. I like that Visual Studio Code, VS Code, has the ability to open the SDK config editor like this, but I feel like I still struggle a little bit more to navigate it versus the menu config. Component config. Yeah, it's component config that I want to be in. Wi-Fi provisioning manager. Wi-Fi NVS flash. See if the info says anything. IRAM. Alexa, stop. Yeah, it is a little overwhelming this way. For those that are new to this, the other way you can do this, make this a little bigger, is need to source is if you have idf.py, you just do idf.py/menu config and hit enter. And it'll show you like an old BIOS menu, like throwback style, like this. And then you can go into like component config and then come down here to where we just were, like Wi-Fi provisioning manager. And you can look at it this way. So it's a little bit easier. I agree with Sparky. It's a little bit easier to navigate this way. The thing I really like about the VS Code is when I open it like this, is I can search, like, and it'll just pull up like, you know, oh, I want to do something rated to BLE. I just type it in and it just filters down to all the BLE settings. So that's kind of a cool thing. Okay. That timer is my bread timer. I'm making some homemade bread and I got to punch it down. So I'm gonna step away for 60 seconds, maybe a little longer, and then I'll be right back. Okay, we're back. Thorax, thanks for joining. That was way longer than 60 seconds. I love homemade bread. I make white and wheat. Delicious. White is the batch we're making today, just plain white bread. Okay. I'm trying to figure out why NVS Flash. Why can't I find it? Good. This is how professionals solve their problems. Like, NVS Flash, like this is the header file. It's in its own component. Oh, do I need to include? Let's come way back up here. See, make lists. Do I need to include? Oops. Like I need to let it know that I want to use that component. I assumed it would find it on its own. Love the projects, by the way, that you two are working on. It's awesome. Love when people are getting into it and making stuff. It's awesome. Oh, I wonder. Learning this stuff as we go. Right here. I wonder if this SDK config defaults. No, this is just settings. Well, no, I don't want the jumpstart code. Let's get that. I wonder if we have to include the components somehow. So like this right here, this requires embed TLS. I feel like we need to maybe do something like that. Like we need to requires NVS flash. We're just going to try it. We're messing around here. I don't know. So in main, in our CMake lists, like I have require serial logger. Sorry, what was the format of that? I think we can just we spaces. We do it with spaces. Serial logger, and then let's say, oops, NVS flash like that. Oh, did I still leave that commented out? I did. Let's uncomment this. And let's see if it complains about NVS flash now. It does not complain about NVS flash now. Okay, so I think we figured this out. Wow. Little light on the documentation. So we need to also include Wi-Fi provisioning, I bet. Okay. So NVS flash and Wi-Fi provisioning. Now let's build this. It's gonna have to rebuild the whole thing from scratch. We're gonna get there. Oh, now I'm getting different errors. Log manager. Oh, because those are static. Oh, that's dumb. I know exactly why these are happening. 107, it's going to be inside of a static function. No, log manager should be. That's because I do it in here. I'm not sure if this will work outside. This is a good test of our logging. Let's play with this. I don't know if that'll work. Let's try it. Thorax, I love that you're emulating a BLE keyboard. That is awesome. As a side note, story time. I first got into USB years ago, before BLE. I made a device that emulated a USB keyboard and mouse together. It was like a combo device that I plugged into a coworker's machine, and every like 2 to 5 minutes would type something and move the cursor a little bit, and it was awesome. Hey, this built. We're getting some warnings, but I don't really care about that. I don't think, because this is because we're just messing around. But it built. So I don't really know what's going to happen when we run this. But let's find out. Just plug it in. All right. Let's do Control-Alt-T and do flash and monitor. And see what kind of output we get. Oh man, it's huge. Wow, I wonder what the final binary size is. Yeah, classic prank. Wow, this is taking forever to write. I'm gonna have to IDF pi size this and see how big it is. That might be a... Okay, cool. Like it spit out a bunch of stuff. This is all new. Starting up base MAC address, firmware version, Wi-Fi firmware. Okay. And now it just says provisioning started. Now, you know what? No, let's use we'll use this old test device. That's why you buy a test device. This is a Galaxy S8 that I bought from a local guy. He had owned it for 3 days, dropped it at the gym. I don't know if you could, yeah, the camera's not going to show it very well. It's got a very little like damaged edge and then a hairline crack that you can't even feel across the front here. So it was brand new at the time, like whatever these were, brand new, $600-700. Gave it to me for $150. So check your local Craigslist or other for cheap test devices. Pro tip. And then Google Play. We're just gonna go to the. No, that's not what I wanted to do. I need to go to the store. Play Store. And then I think it's just, we'll just search for Espressive. Espressive BLE provisioning. Okay. I think that's what we want. So I'm just going to install this. Speaking of buying stuff locally, I have no time for this whatsoever, but like I have recently become fascinated in a home server. I have a NAS, like a storage NAS that I put video stuff on and family pictures and stuff like that, but it's starting to fill up. And so I went from how to upgrade my NAS to I've been aggressively local shopping for stuff for a home server. I have acquired a full 42U HP server rack for $80, which I found these things are incredibly expensive, even significantly used and older. Like people want to sell them for like 500, 600, $700. So $80, and then I also picked up a Dell PowerEdge R610 server for 190 delivered that I'm going to start playing with. So, thoughts on having a project channel on Discord? Yeah, done. Like, let's set one up. Um, let me let's open this. If this works in the next like minute, I'll do it. You got an R710. Oh, for about 100. Yeah. eBay. How do you like the R710? Like, how's it? What are the specs on it? Provision new device. It's asking me, I guess you can do this, lets you use like a QR code. So I could even just put a QR code on a display. How rad would that be? Like in the instructions, just like use the QR code, and that's pretty cool. Yeah, that's super cool. I'll have to think about that. So it found my device. I'm going to click on it. If this works, enter your proof of possession PIN. I'm going to enter ABC1234, I believe is what it was in here. It's actually defaulted on the app, but I just want to check and make sure that that's what it was. Proof of possession ABCD1234. That's what they put in here. So I'm going to hit next. I'm not going to lie, I'm liking this so far. Like this app is pretty smooth, like, and it's all open source. Like Espressive provides it. You could reskin it to whatever, so you don't have to write this from scratch. They have iOS and Android ready to go. 64 gigs. Yeah, yours is decked out a little more than mine. So mine is dual Xeon as well. I also don't remember the specs right off the top of my head. It's got 48 gigs of RAM, and then it just had a single drive in it. I actually bought two 900 gigs for like another $50. But yeah, so what do you run Proxmox on it? That's what I'm planning on giving a try, but I'd be interested to know what. Oh, good. Yeah, like I said, I'm thinking about trying Proxmox. Let me know if that's crazy or not. That's what I feel like I want to give a shot to run a bunch of virtualized stuff on. So it's asking me for my network. I select it. I'm going to put my password in here. And hit go. And I'm going to see, I'm looking for output down here as well as we go. And then there's a provision button. Yeah, see, I had password, got rid of that. Check that out. We're connected to the internet. That totally worked. Okay, so you are, is bad. I think that's, yeah, cool. All right, well, I'll have to update you on my server journey as well. In the news of the stream, this totally worked. That was really nice. Like that worked really well. The app is really quite great. Like pretty happy with that. And then it just goes back to here. I'll show you the main screen here if you can see it. Provision, just says provision new device. You click on that, it finds your device. You click on it, and then it'll say, here are your Wi-Fi networks. Which one do you want to connect to? You select yours. Now, I'll go back through this. I don't think I'll do it now. I actually have some things that I got to take care of. I'll be back on the stream later tonight, but testing things like what happens if I type my password wrong? Like, does it handle that well? But right now, we're all connected. And so what I'm going to do just to finish out is let's reset it. And now it should say it's already, yeah. So, oh, wow, that was really fast. Okay, so it's going to come down through here and say right here, already provisioned. And that's because it's got credentials. Now, I'm not going to do this, and this is where it'd be super nice to have just and I don't know why I could buy one for just like $20. A little Wi-Fi dummy router here. Like if I were to change my password, this would obviously fail, but what does that mean for provisioning? I think based on just looking at this code, I would need to handle that myself. And so those are all things that we'll have to figure out, but this is definitely working. What I'm going to do is I'm going to unplug that. The very last thing, is like the third last thing I said before we close the stream out, is let's see. I'm a little worried about this. IDF.py size. That took a long time to program. And so I'm a little concerned. Oh, gosh. Yeah. Wow. The flash total image size, 966,000 bytes. That is, we're going to have to do something about that. And the reason we're going to have to do something about that, gosh, I hate that it's that much, is we want to do OTA. And to do OTA on the chips that I'm using, they're 4 megs. They've got 1 meg. The partitions are, you've got a factory partition and then you've got 2 OTA partitions, and you need the 2 OTA partitions to be able to choose one or the other or roll back. And those OTA partitions are only 1 meg. And so, I mean, without writing any other code for my actual product, like just the
this code to get it provisioned is 966. I mean, we're almost at a meg already. We're almost full on IRAM. Our DRAM's not too bad, but DRAM's not the problem. It's this total image size. So we will look into that another time. I'm going to wrap the stream today. Sparky Thorax, thanks for stopping by. I love the conversation. I love the projects that you're working on. Good stuff there. We will, next time we're back, where are we going to go from here? I'm going to probably play off stream a little more with like, what can we do to get the size down a little bit? I bet this security isn't helping us, but I don't want to compromise on that. I don't want to make it plain text. That kind of defeats the purpose and is also why I think a lot of IoT is broken. So we'll have to figure that out. So anyway, thanks so much for joining. I will, like I said, I'll probably be back on this evening doing some more streaming, and thanks for bearing with me through my bread punching down, and maybe I'll give you a report on how that turned out as well. So thanks so much for watching, and I'll check everybody later.